Today we're going to talk about how to make your light sensor for your light following robot. So the light sensor, this guy, or when it's packaged, looks like this guy, is essentially an LDR, light dependent resistor, in series with another resistor. So the circuit is right here. So I have an LDR, goes to a red wire. The other end of the LDR goes to a 4.7K to a black wire. So this part of a circle is essentially a series circuit. If my LDR was at 4.7K ohms, then the voltage would split evenly between the two. If it was 4.5, I'd have 2.25 and 2.25. If it's a really high value, most of the voltage is going to be right here. If I have a really low value, most of the voltage is going to be right here. So in essence, by altering the resistance, I'm changing the voltage across these two. So I also have a wire right here in the middle between the two where they meet, where I'm going to be measuring voltage. So that's essentially what it looks like. When you solder it, keep your lead short, and then in the end, you tape everything. So I would basically tape this guy, and then tape this guy so nothing can touch in between. So if that makes sense, I'm separating this guy from this guy so that nothing touches. So I have this package right here. Let's go ahead and see if it works. So I have it plugged into the red to plus V and the black to 0V. I can go in and use any one of my blacks on the breadboard. So if you don't have space on the pickaxe, any black on your breadboard, any ground, this ground would do. And this guy, the red one, you could hook to plus V also on your breadboard if you want. If you have one, not the power, not the power supply power, but plus V from the breadboard. All right, to make it easier to measure, I put an extra wire into 0V and I left this guy open. So let's do some measurements right here and see what we read. Also, when you do this, eventually I'm going to be plugging the yellow wire into pin 4 on your pickaxe. Pin 4 also has the light sensor right here. So you gotta turn dip switch 4 right here has to be off. Okay, otherwise it's gonna read a combination of your light sensor out there and the light sensor right here. So let's see what this reads. I'm gonna turn it up right here. I'm gonna hook it up and I'm gonna hook it up. Bam, turn my pickaxe on. Oh, my lead came off. There we go. So right now I'm reading, as you can see, I'm reading about 3 volt, 2.93. If I cover this guy with my hands, you can see it goes all the way down to 0. So that essentially means in a series circuit, I lower the resistance when it gets dark. I'm raising my resistance when it gets light. If I took my phone and turned my flashlight on, if I shine it right into it, you can see it approaches 4.6, which is probably about my plus V. So basically, this guy will go from all the way from 4.6 all the way to 0 if I put light on that. So what we're going to be doing is we're going to use this guy to see what's the voltage on white, what's the voltage on dark. And you can see mine goes between 0.8 to 2.5 in that range. If I was using pure digital electronics, anything from 0.0 volts to 0.8 gets read as a digital 0. Anything from 1.2 to 4.5 gets read as a digital 1. So in my case, I would see a digital 1, I would see a digital 1. It wouldn't make any difference. It would interpret both of these guys as a digital 1. So we're going to have a method of doing this where I read this voltage as an analog voltage, and then I'm going to convert it into a binary number between 0 and 255. Remember that that 255 1111, 1111 is the highest number I can represent in a byte. So let's go through the calculations on how to figure out, like in your program, what number do I need to program this for? So the first thing I'm going to do is I'm going to measure my battery voltage. So my battery is 4.7 about. I'm going to get 4.7 volts. So my battery, move this out of the way, 4.7 volts. Okay. So the next thing I'm going to do is I'm going to basically, my pickaxe is going to take a voltage, and if I had 4.7, it stores that as 255, or a digital byte that's 1111, 1111. If it's 0 volt, it stores it as a digital 0, binary 0, 0000, 0000. So anything in between that gets a different binary number. So the first thing I'm going to take 4.7. I'm going to divide it by 256, because 0 to 255, how many different locations in a binary byte is 256. So I go 4.7 divided by 256. So it's 0.0184. All right, so now I'm going to take my two numbers. I'm going to see what does it read on white, what does it read on black. So I go the white equals the black equals. So I don't want to put it all the way down because I'm going to be shielding. You can see I'm shielding all light, so a little bit above the ground and consistent. So it's 2.5 volts on white. It's 0.8 on black. So I'm going to go 2.5 volts and 0.8 volts. Okay, so now I'm going to figure out what's the binary equivalent of those numbers. So I go 2.5 divided by this number, 0.0184. On this guy, I go 0.8 divided by 0.0184. So let's do those calculations. So I have 2.5 divided by 0.0184. So I get 136. On this guy, 0.8 divided by 0.0184, I get 43. The average between the two, so 136 plus 43 equals 179 divided by 2, about 89 or about 90. So basically, whenever it reads 2.5, it's going to read the binary equivalent of 136. Whenever it sees black or 0.8 volts, it's going to read the binary equivalent of 43. The difference between these two, or the average, is 90. So in my program, when it reads a number, I'm going to do I'm going to do something on 90 or not. So let's take a look at my program really quick. So I go in, and I have my program right here. So I have main read ADC, so read analog to digital convert. So it reads a voltage and it converts it to a digital equivalent. Okay, I read it on pin 4. Remember, pin 4 dipswitch must be off. And I store it in the variable B0. So it's going to read a number. It's going to convert it to a binary equivalent, anywhere between 0 and 255. If it reads 0 volts, it's going to, that B0 would be exactly 0. If it read 4.7 volts on my battery voltage, it would read 255. In my case, I was reading, again, 136 for white and 43 for black. The difference between them was 90. So in this guy, I go, if B0 less than 90, then high 1, low 0. So if I have my motors on, right, I turn one motor on, the other one off. Else, that means if it was not less than 90, so greater than 90, I do the opposite, high 0, low 1. And then it goes back. So basically, it's reading a number and then turning 1 on and 0 off. And if it's greater than 90, it's turned 0 on and 1 off. So I already downloaded that program. Let's see if that works. So now I'm going to take this guy and I'm going to plug it into number 4. Whoa, all my wires are coming out. So this guy goes to pin 4, if I can get it in there. Houston, we have problems. Pin 4, good, I think it's in there. And then this guy's going to go to plus V. Bam. So now see if this guy works. Is my 1 not working? My 1. So you can see whenever it's on white, the 0 is on. Whenever it's on black, the 0 is off. My yellow LED may not be working. But here you get the idea, right? On, off, on, off. So I can differentiate between white and dark. So the first, you just show me you can turn on and off an LED on white and dark. Okay, when you mount it, so when you're ready to mount it on your actual robot, you want to tape it out front. So see how it's taped? So I tape it out front so it's always the same distance away from the ground. Okay, then I'm also it's going to read different things whether it gets light or shadow. So I also put an LED out that basically lines not directly on it, but would light the ground in front of it and come back. Then I'm going to ensure that I have constant light. But that's going to be how you make and how you test your light sensor.